This is CPM Precalculus Chapter 1, number 98. So we're given a triangle DOG, so triangle DOG, and angle D is 64 degrees, angle O is 38 degrees, and side DO is 8 inches. So we're asked in part A to draw a diagram roughly to scale. Okay, so how do we draw it roughly to scale? Well, let me just overview quickly. We know that this right here, these are perpendicular lines and they intersect at 90 degrees. So we know right here this angle is 90 degrees, right? We cut that in half. We know that half of 90 degrees, this angle right here, is 45 degrees. And we cut that in half. 45 divided by 2 is going to be 22.5 degrees, right? So this just gives you a rough idea of scale. We want to look for 64 degree and a 38 degree angle in our triangle. So drawing that to scale, 38 degrees is going to be more than 22, but less than 45. So it's going to be something close to this right here, right? So let me start off by drawing our 38 degree angle. Oops. So our 38 degree angle is right here, and this is side O, right? And then we're going to connect it. 64 degrees is going to be bigger than 45, actually in less than 90. Okay, it's 45 plus 22.5 is going to be 67.5, so it's going to be less than here. It's going to be something like this. So something like this, okay? So that is 64 degrees, and that's vertex D, the corner of our triangle D and O, and then this is vertex G, okay? And we know side DO here is 8 inches. And there's our diagram roughly to scale. Okay, so B, we're asked to solve the triangle completely. Solving the triangle completely, we know, is finding all 3 angle measurements and all 3 side lengths. So that's looking at angle O. We know already is 38 degrees. Angle D, we know already is 64 degrees. Angle G, we need to find. Okay, side OD, or as we're given it, DO, is equal to 8 inches, right? Side OG or GO, either way, OG we need to find, and GD or DG, or GD, we need to find this side as well. Okay, once we find all 6 pieces of information about our triangle, we have solved it completely. So let's do that. Let's go over here, and let me start off by looking at the angles. If we have 2 angles of a triangle, we can always find the third angle. That's because if we add up the 3 angles, add 3 angles in a triangle, and the sum is 180 degrees. This is true for all triangles. True for any triangle in the world. Okay, no matter what it is, if it's a right triangle, if it's an obtuse triangle, if it's an acute triangle, if it's scalene, acute, isosceles, no matter what, this is true. The sum of all 3 angles is 180 degrees. Here we have 3 angles, angle O plus angle D plus angle G. We know we add them up, we get 180. Angle O is 38, so I'm just replacing it. Angle D is 64, I'm replacing it. Angle G, I don't know, so I'll leave it as angle G. Okay, combine like terms, 38 plus 64 is 102, plus angle G is 180. Okay, subtract 102 from both sides. We are left with angle G is equal to 78 degrees. Okay? So I could go over here and plug in angle G is equal to 78 degrees. Alright, so let me just label this a little bit. This was solving for angle G. Alright, so now we need to find side OG and side DG. So the way we're going to do that is using our law of sines. So here we're going to look for OG, right? And I'm going to even write in 78 degrees here in the triangle. So to find side OG, okay, so previously we would have to kind of make this, like break up this triangle and find like another right triangle here and do some work with our trig identities and our trig ratios. But now we have the law of sines. So let's use the law of sines. Right? The law of sines is basically saying for any triangle, again, that if you look at one angle, so if we look at sine of angle O here, and the opposite side, well, the opposite side of angle O is, you look where it opens up, it's this side right here. We called it DG. So for any triangle, all of these ratios are going to equal to each other. Okay, for this specific triangle, right? It's only for this triangle, but it's true for every triangle that if you look at the sine of an angle divided by the opposite side, it's equal to the sine of the other angles, so sine of angle G and sine of angle D divided by the opposite side of angle G is going to be side OD or DO, and sine of angle D over side OG over here. So all these three ratios are equal to each other. That's what we know from the law of sines. So angle O, let's substitute in what we know is 38 degrees. DG, we don't know yet, so let's just leave it as DG. Sine of G, G we know is 78 degrees. DO, well, DO we know is 8 inches. And D is 64 degrees. And OG we do not know yet, so I'll just leave it as OG. Okay, so to find OG, we have three expressions that are equal to each other. I'm looking for OG. OG, let me put right here, is right here in red. So I'm going to use the two expressions, these two, because this one we have an unknown, and I want to just use these two to solve for the one unknown first. So I'm going to ignore this one here and just have sine of 78 degrees over 8 inches equals to sine 64 degrees divided by side OG. Okay, so now that we have this equation, we can solve for this one unknown. Remember, this is not O times G. This is side OG, right? So to solve for that, we can multiply both sides because we want it in the numerator. Remember, we want it in the numerator and we want to isolate it. So if we multiply both sides by OG, we get rid of OG in the denominator, and we're just left with sine of 64 degrees on the right. And on the left, we have OG times sine of 78 degrees divided by 8 inches. Okay, so if our goal is to solve for OG, we want to get rid of this multiplication by 78 degrees and this division by 8. So we're going to multiply by 8, so these cancel out, and divide by sine of 78, so these cancel out. Okay, this is not degrees, that's inches. So if we do it on the left, we do it on the right. Okay, these cancel out, these cancel out. We get OG is equal to sine of 64 times 8 inches divided by sine 78 degrees. Okay, let's plug that into our calculator. sine of 64 degrees times 8 inches divided by sine of 78 degrees. Okay. Oh, I need to go here and make sure I close my parentheses. Otherwise, I'm going to be multiplying by sine this whole thing. Okay. There we have it. OG is approximately, I'm going to round this, is approximately, if I look at just two decimal places, 7.35. This 0 makes this 5 not round, 7.35 inches. Okay? Let me get rid of that. And I'm going to go up here and write OG is 7.35 inches. I'm going to even add it to my diagram just so if I look for reference, this is 7.35 inches. Okay? Now lastly, I want to find side GD. Okay? So side GD, let me go over here, GD. Okay, so here I used these two expressions. Now for side GD, I want to use this one, right, because it has my GD or DG, and this one because it has no unknowns. So this, I could ignore this expression this time and just use these two are equal to each other. So I have sine of 38 divided by side DG, or I'm going to call it GD just to be consistent, equals sine of 78 degrees divided by 8 inches. Okay, so to solve for this, remember I want to multiply both sides by GD. That cancels this out. Sine of 38 degrees equals to sine of 78 degrees times GD divided by 8 inches. Now I want to get GD alone, so I want to, let me draw a line here so I don't get confused. So I want to multiply by 8 to cancel this 8 in the denominator and divide by sine of 78 degrees to cancel this. So I have to do that on both sides. Right, so this is going to cancel out, this will cancel out, and we're left with GD is equal to 8 times sine of 38 degrees divided by sine of 78 degrees. Okay, so let me bring out my calculator. 8 times sine of 38 degrees divided by sine of 78 degrees, and I get that's approximately 5.03. This 5 here, because it's 5 or greater, makes this number round up, so it's 5.04 inches approximately. Okay? So I can go up here and this is GD or DG, and I know that is 5.04 inches. I'm going to put that in my triangle as well. And that right there is solving the triangle completely. I have all three angle measurements and all three side lengths. Okay, so finally I need to do part C. So part C is asking to calculate the area of our triangle, of triangle dog. Okay, so we know the area of a triangle. The area of a triangle is just 1/2 base times height. Alright, so if we look at the triangle, we could look at any side being the base. For example, if this triangle were to rotate, it could look like this. Well, so far we have this, we have O, D, and G, right? If we rotated it and had side DG on the floor, it would look kind of like this, right? If we rotated to have side GO on the floor, I'm saying like just parallel to our horizon or x-axis, GO, then we would have it looking something like this. Something like this, okay? Okay, so we know the area can be calculated as base times height. Okay, we could use any one of these bases, but if we use side OD as the base, the height is going to be this. We at a 90-degree angle, we're going to connect angle G to the base. Okay, because the height is the height at a 90-degree angle. So the height is different depending on which side you're using as the base. Okay, I just want to make sure we are clear with that. So you can calculate it using either one of these as the base as long as you're using the corresponding height of that triangle. Okay, because these are all the same triangle, but the height changes if you change the base. Okay, so let's look at the triangle in this dimension just because. And we know the base then is OD, which is 8 inches. Well, and the height then is what? The height, we have to remember, is going to be this side right here. Well, if we split that, now if we just split the triangle up, right? And if I cut it right there at the height, so if this is my height, if I cut it, then we still have height here. This, we know we took away this part right here, right? So this is D, this is still vertice O and G. So we took away that. So we know that this is still 7.35 inches. This is 38 degrees still. This is now 90 degrees. We no longer know what this is. We could find it easily, but we don't know it now. We don't know what this side length is because we cut off this section. We could also solve for that if we want, but we're only interested in solving for the height. Okay, so how do we do that? Well, we use our trig identities. We know SOHCAHTOA, right? SOHCAHTOA, we know sine of 38 degrees is equal to the opposite side, right? This is only true for right triangles. So good thing we have a right triangle now. The opposite side is going to be our height. The hypotenuse, remember, is the opposite from the right angle, which is 7.35 inches, okay? Cosine of 38 degrees, well, we know that's the adjacent side. Well, we no longer know this side length. Well, we know the whole side length, right? We know all the way to here, but we don't know this, just this section, so we don't know this. Over hypotenuse, we know that's 7.35 inches. And tangent of 38 degrees is the opposite. Well, that's the opposite of O. Angle O is the height, right? That we're looking for, the H. Adjacent, again, is we don't know. So which one of these three will help us? Well, not this one, but sine. So sine of 38 degrees is equal to H divided by 7.35 inches. Now let's solve for H. So to do that, we multiply both sides by 7.35. That will cancel these. Do that to both sides. Right. Bring out our calculator. We get 7.35 times sine of 38 degrees. And we get H is approximately 4.525. So that 5 rounds the 2 to a 3 is our approximate value for H. Okay. So we have H, but we're not done yet. We're trying to calculate the area. So we know that we have our base is 8, and our height we found is 4.53. So let's put it into our area formula. We get 1/2 base times height, and that's equal to 1/2 times 8 times 4.53. Oops. And we get 18.12. And it's approximately, because remember we approximated here, we rounded that. So once we start rounding, we should use the approximate symbol. And our unit area is going to be, remember the base is in inches, the height is also in inches. So when you multiply inches by inches, you get inches squared. So 18 inches squared is our approximate area for triangle DOG. Okay, 18.12 inches squared. We calculated the area. We drew our rough scale of the triangle. We solved the triangle and we calculated the area. This ends Precalculus Chapter 1, number 98.